Hi guys, today on the channel we're going to be making an Arduino version of the TV Begone device, or the TV Killer, TV Blaster, whatever you want to call it. It's a device that's going to turn off all the TVs in the close vicinity. To do this we're going to use a high-powered infrared LED, we're going to use the Arduino Nano, we're going to use a MOSFET driver, an 18650 battery, a controller board, a button and a project box. Now the reason we need to use the MOSFET here is because this high-powered LED is going to take a little bit too much current that the Arduino Nano can put out off one of its output pins. So we're going to use the output pin to trigger the MOSFET, which will then in turn trigger the LED. Now all the different off codes are all held in the program of the Arduino Nano, and it's when you press the trigger button it's going to cycle all through them in turn. Flash the off codes through the LED and turn off all the TVs in the vicinity. So first thing I'm going to do, first thing I've already done is drill some little holes in the front of the lid of the project box to fit the LED in. So the way it's going to work is this is going to sit on the front like this. I'm going to get some M2 bolts and just bolt that onto there. So this is what the device is going to look like. The trigger button is going to be on the top. So the idea is that you just press the button, put it on a table, and it flashes away its codes and all the TVs around turn off. Nobody knows what's happened. So the way we're going to fit this in the box is the battery is going to go there. I'm going to use a hot glue gun to glue that into the base there. Then the controller board is going to fit into the bottom like so that we can plug mini USB in to charge that up when it's needed. So I'm going to do those things now. Okay, there we go. By the power of editing, we've now got the infrared LED bolted onto the lid of the project box. We've got the 18650 battery holder glued down into the project box. We've got the power board glued down into the project box. We have a switch connected, and we have got the button glued in as well. A little bit messy, but we don't mind about that. So the only thing we need to do now is we need to wire the switch to pin number D3 on the Nano. We need a wire coming from pin number 2 going to the trigger on the MOSFET. We need a wire going from voltage in and ground to take the power into the Nano, and we need a wire from 5 volts that's going to go to the power the VCC on the MOSFET. Then we need to connect all the grounds together and we should be ready to go. So let's do that now. Okay, now that we've got all those wired up, we've got the trigger going to the signal pin on the MOSFET. We've got the switch going to pin number D2 on the Arduino. We've got 5 volts wired up to the 5 volts on the MOSFET. We've got all the grounds ready to connect all together. All we need to do now is connect the power coming from the battery, from the switch, over to the voltage in on the MOSFET, and also then connect the voltage in to that same, for the Arduino, to that same connection. We need a ground wire coming from the MOSFET, connect all the grounds together, connect the infrared LED to the output of the MOSFET, and then we're ready to test it. So I'll just connect all those up now and then we'll give it a test. Alright, we've got everything wired up now. All the grounds just twisted together for now while we give it a test. I'm probably going to put some insulating tape on the back of the Nano and just on those pins in there when we've ensured that everything works, just to make sure nothing shorts out when it's inside the box. Okay, so if we just make everything fit nicely in here. There we go. Pop the lid on. And now for the moment of truth. Let's go and give it a test. Alright, here we go. So as you can see, the TV is very clearly on. Here's the device. Switch it on. Press the button. There we go. TV didn't stand a chance. Okay, so I'm going to do some more further tests out in some further locations, but I'm quite convinced that it's going to work fine. I'll report back if it doesn't, but from all intents and purposes, it's doing what we designed it to do. I'll leave a circuit diagram in the description to help you, and also I'll leave the code in the description too. Okay, with all that being said, thanks for watching. If you could give me a like if this is any use to you, or if you've had fun watching, that'd be really useful for me. Thank you so much. And with all that being said, I'll catch you in the next one. All right, bye.